welcome to the garden. Today we have acquired a stepper motor for some good fun. So let's get into her. Oh, good. For the new users out there, there's a thing. There's some bin filler. There's the powerometer. And the motor. And bin filler. And just make sure there's nothing hidden under here. Nope. Bin filler. See ya. I'm not going to risk that with the knife. Not on camera anyway. You'll do, baby snips. These mini side cutters that of course don't quite cut flush. Will do. More bin. So we got, this is a 4-wire. Which means it's a bipolar, I think. I hate these wires when they're all coiled up. So this is, I believe, asymmetrical. So yeah, it doesn't go in that way, but it will go in if you get it right. And yeah, it's got the liney up slots on the top, so that's in. There we go, that is a NEMA17, which means that I think it's 1.7 inches from side to side, or is it 1.7 mountain hole to mountain hole? Pretty sure that it's side to side, or edge to edge. That's 1.7. 1.7 side to side. If you get a NEMA21, 2.1 inches by 2.1 inches, so on. So, could have just looked at this card. That probably tells us. Yeah. Oh well. So, what's useful? Amps 1, okay. Resistance 25 degrees C. 3.6 ohms plus minus 10. See about that. Right, must be you and you. Nope. .6, and you must be the other one. 4.6. So that's green and red and black and blue. It's about 21 degrees in here. Oh well, no matter. 4.7. Holding torque, don't care. Step angle 1.8, which is 200 per revolution. Step accuracy is plus minus 5%. I guess that is total. So if you do 200 steps, you could be 5 steps out. Maybe. Temperature rise max 80. Guess we'll try and check that by leaving it powered in some way. Ambient temperature minus 10 to 50. Well, that's a lie because I've used these. Is it the same motor? Oh, I can't remember. I'm pretty sure that it was. And I've used them in minus 20 and they work fine. Don't do it though, it's minus 10. Never go off the end of the data sheet or whatever this is. Insulation class, don't care, blah blah blah. Boring. So, pin numbers, which are a pain because you never know which end to start at. So your A winding is the black and the blue, which is pins 1 and 3, which is what we found when we put the multimeter on it. And phase B plus B minus is green and red, which is also what we found. And then we have this diagram table here that basically shows you how to energize all the 4 coils, and you'll notice that the pluses go down. It basically just sort of steps its way through and just moves the field around, and then the motor follows it. And if you go 1, 2, 3, 4, you go clockwise, assuming you've wired it up as this is, and if you go 4, 3, 2, 1, you go counterclockwise, again assuming you've wired these coils up this way. Right, we're going to wire up this here stepper, driver L298N, is it? It's a something. Get out. L298N. That's it. So this has got out 1, out 2, out 3, out 4. Enable A and B, and you leave the jumpers on it, from what I remember. In 1, 2, 3, 4. So 1. This is if I remember correctly. Enable 1 goes to out 1, 2 goes to out 2, 3 to out 3, and 4 to out 4. And here's the secret with these things: you can wire these any way you want as long as you're consistent. So with that being said, let's find a small Phillips. I don't know which one of these is the right size. It's a little bit small, mate. Turns out, not so easy. Never work with children, animals, or cheap stepper drivers. Which one's this? This is that is 12 in ground and 5 volts out. Now with these, if you put 12 volts or below on, again from memory, check it if you're going to do this. If you have the jumper on, it means you can power your microprocessor with the 5 volts. And if you're above 12 volts, you take the jumper off and you can't. So I can gather it's probably this component here that takes up to 12 volts and then regulates it down to 5 volts. Because it'll be a voltage regulator. I was expecting the regulator rectifier, as found on the 2-wheeled vehicles of choice, but not. Okay. Now, let's find out. Because we've done this before, got a harness here, and the way this is wired is that we've got this one. This should be the first coil. So it's got the red is 1 coil positive and the black is 1 coil negative, which according to this is 1 is red, which is this one, which will go to black on our stepper, and it will go to A plus. Oh yeah, sorry, I got very confused when looking at this. So 1 goes to A plus, and then 3 is A minus, which is this black one here on pin 3. And then on the other side of this, we've got this fetching yellow and black pair, and yellow, which is pin 2, goes to positive B, and then the other black goes to B negative, which is 4. And the way this will be wired on the H-bridge driver, the 298N, is input 1, input 2 for this one, input 3, and then input 4. So these will go in pairs on these here connectors. So let's give it a go. So this in, out 1, which is red. These have not been used on one of these before. They're a bit too long, but I'm sure it'll be fine. In you go, mate. They're in. So 3 and 4, which is yellow. And oh, you go all the way in there. That's very strange, isn't it? Well, it's either operator error or the fact that it's inconsistently made. And I'm going to guess it is very probably the former. Right. Your tighty. Tighty. Is that tight? Tighty-ish. Well, I'm just curious now. I'm just going to try and get these in a little bit more. There you come. Operator error. Oh well, not important. In we go. Okay. So red goes to black. And as long as we do that, we know this is all be wired correctly because it's been used before. And we're filming it, so what could possibly go wrong? So red to black, which makes sense because I typically wire these things so that those two sides with the pin access are together and then the non-access side is together. So looks like I've used it before and done something similar. Stepper. What I'm going to do is got this flexi shaft coupler, and then this hex Allen key we've used for something else. Save that off. Depending on, I know what will happen is it'll rotate at the wrong frequency and you won't see it without that bit sanded off a bit. Let's tighten this up. Tell you what, these things are the most awkward things to use, but they're great to put under your bike seat for when you break down, because you can get every single bike apart to practically back to the engine with just a set of hex keys. Now, what I should have done, of course, is check this first to make sure it actually goes on. Oh good, which it doesn't. Is that hitting the hex? I think it's hitting the hex. Yeah, so it was hitting the hex, so it does go on. My bad. I would say never work with children, animals, H-bridge drivers or stepper motors, but I think fortunately I appear to be the common factor here. I'm sure my work colleagues would agree. Okay, that's on, so we should be able to see that spinny one way then the other. Power. And what do we say that your ground. So in you go. And you are 12 volts. In you go. sure that'll be fine. And then power supply and red to red and black to blue. There you go, mate. Arduino knockoff, and you need a ground, and you go to this blue here so that all the ground's together, so we're all speaking the same language. And here's where this jumper ain't long enough. So I'm going to go from 2, because I think that's what I've done it from, and then you need to go to enable 1. So you go that way. So now we've got stepper onto these two outputs here. We've got the Arduino driving these enables here, and we've got 12 volts going into here, and that is positive into 12, and then ground. So we should be good. So when we plug this, what we'll do is we'll turn the power on first and see if any smoke comes out of it. No bang yet, and a very ominous red light. I'm sure that's a good red light. And you are 12. That's good. So now when I plug this Arduino in, it should already have the program on it, and this stepper will spin one way, and it'll wait for, I think it's about 2 seconds, and then it'll spin back the other way. By driving the inputs, I'll show you the code now. Right, what we've got on the code for the stepper motor attached to the L298N H bridge is initially we declare our 4 pins on our Arduino as outputs. Declare them as constants with the numbers on. And the reason that I've done it like this instead of hard coding them is so that I can change one number here if I move it to say 8, and then it'll write the other pins accordingly as well. And the A plus minus B plus B minus are to match up the inputs on the 298N H bridge to the outputs that are on it. But as mentioned, they are sort of arbitrary, and you can do them however you like as long as they match up and refer to the same coil, or the same coil arrangement as your wiring is. Set up, serial begin, just so I can print this line out, so if there is any trouble you can work out if your Arduino program's actually starting and running or not. And then we just loop through the 4 pins declared here and declare them all to output. We've then got a function called takeStep that receives an argument which is in this case it'll be a sequential number int I passed to it in the loop, and from there it'll work out how to write the output pins to correspond with the step that we need. So because we're writing this in code, we've got our step number switch starting at 0 and going to 3, which corresponds to case 1, 2 and 3 on the card, and hopefully I can work out how to get both of them, both this and that, on screen at the same time. So initially we've got step 1 on the card, which is A plus high, B plus high, A minus low and B minus low. And then we've got the second step, which is A plus low, B plus high, A minus high and B minus low. And then the third step, which is A plus low, B plus low, A minus high, B minus high. And then the fourth step, which is A plus high, B plus low, A minus low and B minus high, which is just exactly as it's written on the card. And then we finally got the park one, so that we don't need, because we don't want the holding torque, we just want to write everything low so no current flows when it's not moving. And then into the loop we're declaring our steps per revolution, which is stepper specific and 1.8 degree step angle, from the card is 200 steps per revolution. Using a 10-second delay between steps. Okay, you should never use delay in an actual thing because it's a blocking function. Whole other argument. But this is very, very simple, and just to demo this, and basically it's the sort of thing I plug into a stepper motor just to check it works when you pull it out of the box. And we're using 10, it's not too fast, not too slow, ballpark where EEVs move on fridges. Going on to the next bit, we've got the for loop that says for int I equals 0, I less than steps per revolution. If you do less than or equal to, you'll get an oboe error, so you want to make sure that you've got just less to, or you can start I equals 1 and then do I less than or equal to steps per revolution. Choice is yours, but in this instance we're programmers, so we're starting at 0 and then we're going to less than. If you're a biologist, you can start at 1 and then go less than or equal to. The choice is yours. And then I plus plus, we increment I. And then we're doing take step I, which is going from 0 to 200, modulo or 0 to 199, less than. Modulus 4, which means that it's going to go 1 or 0, 1, 2, 3. And then when you get to 4, it goes back to 0, 5, it goes to 1, and so on. And then we do the step delay. So what this is going to do is continually call the take step function, and it's going to pass in a number that's basically going between 0 and 3 as the valve opens up, which turns us clockwise, and it goes through the steps in this direction, so down each time it goes through it. And then after that, we're going to park it and de-energize all the coils, delay for 2 seconds, and then we're just going to same thing but the other way. So we're taking I equal minus steps per revolution, and then we're going to I less than or equal to, or less than 0, and then I plus plus to count up from minus 200, which is the steps per revolution, and then up until, or when I equals 0, this criteria won't be fulfilled and we'll exit the loop, and then we'll park it again, delay for 2000 milliseconds, 2 seconds, it goes back. But this time, because we're running it in the counterclockwise direction, the code's going to run this way. So it'll start at 3 and then go 2, 1, 0, 3, 2, 1, 0. By driving the inputs, the driver, which in turn drives the outputs, in the way described on this step thing here, apart from because I wrote it in code, I started at 0 to 3, and because this was made by biologists, they do 1 to 4. So let's find out. Alright. That is the wrong wire. Well, we'll be back when we've worked out which way round, or which wire we've got the wrong way round. Okay, so we had the code the wrong way round, and we'd coded it so that it must have been the way that I last used this on a stepper, so that the input 1 should have been A plus, which we had. Output 2, should have been, well, the input output's the same thing, right? Depends if we're talking here or here. But this goes directly to here, and this goes directly to here, this to here, this to here. We were doing input 1 for A plus, input 2 for B plus when it should have been A minus, and input 3 to B, whatever the way is that makes those two swap round. So basically we have, instead of having the, come here, so instead of it being A plus 1, B plus 2, A minus 3 and B minus 4, we'd wired it and coded it in such a way, as I say, it doesn't actually matter which way you do this, as long as you're consistent between them. You can call them whatever you want. We were doing A plus for 1, B plus for, is that right? Not even sure now. Either way, we had a B, I think it's the B plus and the A minus was swapped over in the code. So we've changed that back, and we'll power it back up, and 12 volts again. And now when I plug this back in, it should go one way and then the other. That looks about right. So if you get your wiring right and you get your coding right, and you can get the screws out of this alright when you take it out of the anti-static bag, that's how you make a stepper work. That's all she wrote. Well, as it turns out, this motor is pretty hot to the touch, but it's still touchable, so it's not that hot. But unfortunately, this heatsink on this mini H bridge is getting very hot, and because electricity starts to break down at around this temperature, we're going to have to call it a day there. Toasty, but not too toasty at this. Hot, ouchy hot.